Okay, good morning, afternoon, or evening, everybody. Welcome to the TRMM and GPM Precipitation Products and Data Services at the NASA Goddard Earth Science Data and Information Services Center, or GES DISC. This is your host, Jennifer Brennan. I do have 2 p.m. Eastern Time, so we're going to go ahead and get started here. And for those of you who are just logging in, we have 2 optional polls at the bottom of the page that we do appreciate your feedback on. So let's begin first by going over a few housekeeping items related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or if you have any questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. This webinar will be recorded, and we will post it both to our online Earthdata Adobe Connect catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. The URL will be provided to all of you at the end. All presentation files will also be available for download at the end of the webinar. As far as timing is concerned, this webinar will be 1 hour long. We've allocated 45 minutes to the presentation and live demonstration with another 15 minutes for the question and answer period. After our speaker has finished his presentation, what we'll do then today is we'll move to a final set of polling questions. The question and answer period will follow directly after the polling questions. As I mentioned earlier, you'll have an opportunity to ask your questions throughout all portions of the webinar except during the live demonstration by using the Q&A pod. Due to the large number of participants, questions will not be answered using the raising hand function. It has been disabled. We will take all questions again via the Q&A pod at the end. And then one final note, depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. All right, what I'd like to do next is move to our agenda. Let me pull this up for you here. The first 20 minutes or so will be spent on an overview and introduction to the TRMM and GPM precipitation data products and data discovery information. From there, we will transition to a live demonstration accessing precipitation data using Giovanni. Finally, we will wrap up highlighting key data services for working with these data. With that, it is my pleasure to introduce today's speaker, Dr. James Acker, Senior Support Scientist with the NASA Goddard Earth Sciences Data and Information Services Center, or GES DISC. Dr. Acker?
Hi, everyone. Wait for our presentation to show up. Okay, I assume everybody can see it. As Jennifer said, I'm going to be talking about our precipitation products and data services from 2 main missions, TRMM and GPM. And I definitely want to credit the first author of the presentation, Zhong Liu, who will be available to answer questions after the webinar presentation is completed. Zhong has been our long-term precipitation data expert and put together most of these slides and can really speak to pretty much every aspect of the data and services that we have here for precipitation data. Okay, here's a quick outline of what we'll be going over. We'll talk a little bit about who we are, the NASA Goddard Earth Sciences Data and Information Services Center. We'll be talking about our TRMM and GPM and other precipitation data products. And we'll be talking about our precipitation data services. And we will talk about and give a short demonstration of our Giovanni system. And at the end, we'll talk about some of the things we've developed for applications and give you a quick summary. And there will also be URLs available. You'll see them on the slides, which are available after the presentation. But at the end of the presentation, there'll be clickable slides, clickable URLs that will take you to some of the things you'll see today. Okay. Well, as we know, precipitation is a very critical variable in the global hydrologic cycle. And not only is it something that is important around the world, it also has considerable influence on our daily lives. There can be droughts, there can be floods, such as what has just afflicted Louisiana. It can affect our outdoor activities like sports and picnics and working outdoors, all of that. And it can affect the spread or non-spread of diseases. So here's a picture of the Yangtze River near Chongqing during the 2010 drought in southwest China, and the river was flow was drastically reduced, as you can see. And earlier this year, there was some pretty dramatic flooding in the U.S. Midwest, and you can see evidence of that in this picture. And as we said, there is flooding going on. Recovery is beginning in Louisiana, so it's very topical, as well as something important to climate and weather. Okay, as I said, we are the NASA Goddard Earth Sciences Data and Information Services Center, and we are located at Goddard Space Flight Center, which is in Greenbelt, Maryland, a suburb of Washington, D.C. And the GES DISC is one of 12 NASA Earth Observing System Data and Information System, known as GES DISC, Distributed Active Archive Centers, which we call DACs, that provide earth science data, information, and services to the worldwide earth science research community. Okay, now we have a large number of data and services for those data at the GES DISC. So precipitation is one of our flagship data sets. We also have quite a bit for atmospheric dynamics and for solar radiance, atmospheric composition, which refers to the chemical components of the atmosphere, such as carbon dioxide, nitrogen dioxide, sulfur dioxide, aerosols. And we have quite a bit related to the water and energy cycle, both observational data from satellites and modeled data that relies on satellites or models that NASA produces. So we have quite a bit of global modeling, and those are very popular data sets. Some of the services we offer are data visualization, which you'll see more in Giovanni, subsetting, so you can get temporal or spatial or both subsets of a data set. Format conversion, we offer HDF, NetCDF, ASCII text. There's a number of different ways to do that. We have different ways to look for the data, find the data you're looking for. We have developed quite a bit for the Geographic Information Systems community. We have an expert that can help, that has written quite a bit of ways to convert and use our data in those software systems. So we're working on interoperability, making sure that it's compatible with other types of software. And we have a thing called the Data Cookbook, which provides recipes that extend what you can immediately do with the data on our website. You can download the data and then apply these recipes to do different things with them, such as put them in the GIS, convert them to different formats, things like that. We have a help desk that's available by email, and you can send in your questions and concerns, difficulties, error messages, things like that. So the two things, some of the things we have related to precipitation data. First of all, and we'll talk more about the missions, but we have data from the TRMM and GPM missions. We have hydrology data, and these are from the land data assimilation models, both North American, which is higher resolution, than the global. And so we refer to those as NLDAS and GLDAS, and these are from Goddard's Hydrological Sciences branch. And we also have the atmospheric dynamics. And this is a very popular, widely used data set called MERA. It's actually now called MERA-2. There's a reprocessing of it. So that's the MERA-2 data is what is available from us now. And this is from the Global Modeling and Assimilation Office. Okay, the first mission that we'll talk about is the Tropical Rainfall Measuring Mission, which is referred to very simply as TRMM. And this was a joint mission between NASA and the Japanese Aerospace Exploration Agency called JAXA. And it began in November 1997 and continued all the way through April 2015, which was considerably longer than the expected lifetime for the satellite. And it was set up to specifically monitor tropical rainfall, which does put some latitude limits on the data that you can get from it. Approximately, given the swath scan, to about 45 degrees north and 45 degrees south. The actual limit latitudinally of the orbit was 30 degrees north and south. It had 4 different instruments on it: the TRMM microwave imager, the precipitation radar, the lightning imaging sensor, and the visible infrared suite. TRMM provides orbital and gridded data sets. These are things, orbital refers to level 2 data, which is data the way that it was collected by the satellite. Gridded refers to that which is converted to a global grid. So it's a global data product. And because there were multiple sensors, and because there were projects that put together the sensor data with surface data we have single sensor, multi-sensor, and multi-satellite data sets, all available with TRMM data. Okay, now here's a number of the science objectives that TRMM had. And you'll see they somewhat parallel to what GPM was working on. GPM extended that. But one of them was to advance the understanding of global energy and water cycles by providing distributions of rainfall as well as latent heating over the tropics. And one goal was to understand the mechanisms by which changes in tropical rainfall influence global circulation, and to improve ability to model these, and that in turn leads to the predictions of global circulation and rainfall variability, helping inform climate and weather. We also want to provide rain and latent heating distributions to improve the initialization of models when you run up the model, so that this helps out with both 24-hour forecasts and short-range climate variability. And one of the big things, because you're looking at the tropics, was to get better understanding and diagnosis and prediction of El Niños and La Niñas and the entire southern oscillation cycle, and looking at how the 30 and 60-day oscillations occur in the tropics. We also want to look at how rainfall can affect the ocean thermohaline circulation and the structure of the upper ocean. This is getting very interesting with some effects being seen in the North Atlantic now. And the important thing that was really good about TRMM lasting till 2015 was to cross-calibrate with other satellites, specifically GPM. But any other satellites that were launched in between that could measure precipitation or related variables, you could relate that to what TRMM was looking at. And simply, you could also look at diurnal variability, how much it varied day to night. And finally, it was really one of the first systems to be space-based to measure rainfall. And so that was one of TRMM's greatest achievements, that it just allowed us to look at rainfall around the world pretty much on a daily basis. Okay, as I said before, there's two different flavors, if you want to call them that, of data available from GES DISC: the gridded data sets, which is the global products, and the Orbital. And Orbital is the highest resolution available. It's what the satellite was looking at each time it made a pass. And it'll be bigger on the website if you take a look, but this is an example of what you get when you look at our orbital level data sets. And you can see a variety of them. Over here, radar reflectivity, hydrometeors, that's what's in the atmosphere, and a nice description of them. Shows the date range, pretty much the length of the mission. It also shows you how many files are available, and so you can have a little bit of storage concerns on your own system. You can see how big each of the files is. And this is the gridded data sets. As I said, it's level 3, another way to talk about them. And a lot of these, instead of being orbital, which is looking down at the time, are monthly. They're gridded not just globally, but they're averaged over entire months. You can see several of these are monthly. There may be daily as well, like down here. So this is all the different temporal resolutions available for the gridded data sets, which can have different spatial resolutions as well. Oops. And here's a quick example of what blowing up what one of those rows looks like when you're looking at the available data sets. And so you can see this is the 3B43 monthly. It was quarter degree resolution. It was merged with TRMM data and other data. This included rain gauges. You can see what we can do with it. You can subset it spatially, convert it from HDF to net CDF, and this shows the statistics on the data. Now, more fun, you can see a picture of precipitation radar data here of Hurricane Irene, which happened in August 2005. And we just passed the anniversary. Would that be the 11th anniversary of Hurricane Irene? And you can see it was off the U.S. East Coast. And you can get both a two-dimensional look at the rainfall intensity or a three-dimensional look. You can see the hot towers, as they call them, in the 3D picture of the storm. Okay, now this is a nice busy slide, but these particular URLs will go directly to, they've been set up to go directly to TRMM in some cases. And so Mirador is the name for our current data file search engine, though we're going to have a new one, which we'll talk about a little bit later. So the next one is our new system. It's called the UUI, Unified User Interface, and use keywords like TRMM. Some of the other things we have are the simple subset wizard, OpenDAP, where our files are residing, Giovanni, which we'll show again, and also a web map service, the Open Geospatial Consortium. So we have a lot of different ways to access the data and provide it in the best way that you can try to get it. Now, I just mentioned the UUI, as we're calling it. This is under development, but will very soon become the front page of the GES DISC. And so this is an example of what happens when you type TRMM into the keyword search box, and you get listings of what's available for TRMM data here, similar to what was for temporal spatial resolution, processing level. You can see these are level 3s, begin date and end date. So this will be replacing Mirador ultimately, and this will be the way that you can get the data from our archive. And here's a close-up of what one of the rows looks like in the UUI. This was for the TMPA, which was a multi-satellite product. Again, quarter degree. This is version 7, daily data. You can see the resolutions here. And again, the time range. Now, this was extending to present because some of these were actually continued, even though TRMM ceased operating because they were multi-satellite. They could be continued to extend that type of data set into the present day. So if you click on the blue link, the blue line, essentially, that will go to our data set landing page, and that will allow you to get directly there, get more information, more detailed, and get to where the data reside. All right, so now I'm going to talk about the Global Precipitation Measurement, or GPM mission. And it's a project, really. I've been confused, too, because the M stands for measurement and not mission, as it's very common for many other NASA missions. But this is, again, a joint mission between NASA and JAXA. Got up and started collecting data in February 2014. It's still working, and it is close to global in terms of its orbit, and it also has the capability of looking at not just rain, but also snow. And we'll talk about why in just a moment. It has two different instruments, the GPM microwave imager and the dual precipitation radar. And that's on a satellite that's called the Core Observatory. And that's what really got going in February 2014. Because GPM isn't just one satellite, it's a lot of satellites. And as you can see in this, there's a large number of satellites that contribute to GPM. This is the GPM Core Observatory here, but all of these other satellites operated by NOAA, Defense Department, TRMM, because it's a heritage data set, all of these contribute to what GPM measures. Again, it's got orbital and gridded data sets. I talked about those with TRMM. It's the same for GPM. And GPM is looking at the global water cycle, storm structure, hurricanes, tropical storms, cold fronts, warm fronts, like that. The microphysics of precipitation. How is it forming in the atmosphere? How does snow form? Where does it melt in the atmosphere? Things like that. And all of that will inform our better understanding of how the water cycle fits into climate change. So this is what our precipitation data products for GPM look like at the GES DISC. We have level 1, which is the brightness temperature. Now, if you're not familiar with this, the radars operate in the microwave. And so what the actual measurement made by the instruments in the microwave is called a microwave brightness temperature. Okay, and so that's our level 1. And then you take that microwave brightness temperature and convert it using algorithms such as GPROF into the actual data products you're interested in. Precipitation, hydrometeors. Again, hydrometeors is like water vapor and ice in the atmosphere. And this is being done from the GPM constellations. The DPR is giving us precipitation, corrected reflectivity, combined data products, things like that. And then one of the things that we really want to emphasize, and it's really useful to a lot of people, is iMerge, which is the integrated multi-satellite retrievals for GPM. Okay, now this is something you can get from the archives. It's also available in Giovanni. It's really useful, and it's probably the best way to look at the precipitation data products specifically from the GES DISC. So speaking of which, you can see some GPM data products, and this is Tropical Cyclone Eula, which was last year, right around the end of the year. And so you can see a nice picture of the circulation, and again, you can see the reflectivity, you can see a hot tower here, and this is from the dual precipitation radar. As I said, iMerge is quite useful. This is using iMerge that's available in Giovanni. And this was for a particularly heavy event in Paraguay. And I'm going to show you in just a few moments actually how to look at this with Giovanni. I'm going to generate this image that contributed to this level of flooding in Paraguay in December of 2015. Okay, mentioned the UUI, the Unified User Interface, before. This is what GPM data looks like. And notice this is not just GPM data. This is specifically the iMerge. So you just type in IMERG into the search box, and this returns some of the data sets. And I'm going to talk about what the names of these data sets mean in a little bit later on. Okay, this is a listing for one specific data product, the iMerge 10th of a degree precipitation product. Shows you all the different places you can get it, Simple Subset Wizard, Mirador, through Giovanni, and through OpenDAP. Okay, and here's what it looks like in Giovanni. And we'll be using this in a moment, but same thing, keyword, iMerge, and this shows what's available in Giovanni right here. Okay, and as I said, now it's time to do a short demonstration of our GPM data. Okay, so here we have Giovanni, and one of the things I'll point out with Giovanni is that, let me make this a little bigger. One of the really useful aspects of Giovanni is that you can store a URL you generate as you are doing a session, okay? And then you can share this if you want students, a colleague, a researcher on the other part of the world to take a look at just what you did with Giovanni. You can store that URL. So what I did over here in my text box was I stored the URL to set up the precipitation analysis. So I just copy that text right there and paste it into my search box. I don't need that, but then I just say go. After you say go, you have to refresh. And now it's set up just the way we want it. So you can see here we're looking at the iMerge product. It's called a late run. I'll explain that when we're done. It's set up to be a time average map for the period chosen, and the period chosen is for that period when it was raining very heavily in Paraguay from December 22nd, 2015 to December 29th, 2015. And one of the neat things you can do with some of our plot capabilities is to use shapefiles, which is something we've set up for the GIS community. And so Paraguay has been chosen, okay, and this is just to show you that you have a selection for countries like Paraguay or states in the United States or major watersheds, which is a good thing to have when you're looking at precipitation data or hydrology data. Okay, so we're all set up. So all we have to do is go down over here and click, it's fighting me a little bit, plot data. And so while it's running, you can see that Giovanni keeps you informed of the progress that it's making. And we're looking at half-hourly data. So it's got to go out and get half-hourly data for that entire 7-day period that we're looking at. And then once Giovanni's done with that acquisition of the data, it's going to do a couple operations on it, and the main thing that it's going to do off the bat here is average it. Okay, and it's going to average it for the country of Paraguay, which is the shapefile we're using, and then take a look at it when it's done. While we're waiting, we could take a look at the lineage, which shows you what it's doing, and this is the URL in the system. It shows every URL in the system that it's actually acquiring in order to do the operation that it's operating on. I think it got done. We have a thing that's showing plot there. So in a moment, we'll have an image to show. Okay, and one of the things that you'll see here is that Paraguay is right down here, because this is set up to look at global data. Okay, now if you want to take a closer look at what you've just done, you can just click on the Download As option, and in this case, we'll look at the PNG image. It'll take just a second. And I'm going to open it up with my Earthdata view. And that's what it looks like. Okay, now notice this is actually rendered with the actual size of the pixels from this data product. And so we can do one quick operation. Now Giovanni allows you to do a lot of operations, quite a ways, but you have some plotting options here. And we are going to use the smoothing option, which is more appropriately called contouring, because we're not really operating on the data, we're just operating on the map itself. Okay, now if you wanted to, you could change the data range. You could, there's a whole number of palettes you could use separately from that to perhaps get different information from it. Okay, but in this case, all we're going to do is smooth it out. And just click replot. When that disappears, it's already done. And so now we can take a look at it again as a PNG. You can see it looks like this image that I showed on the slide earlier. And there was a nice large area of precipitation, heavy precipitation in central Paraguay. Now, one of the things you might ask, as you can ask many different questions, is was this unusual, or was this occurring at a time that nobody expected it? And so what we'll do is we're going to go back and use one other aspect of Giovanni here. And my button is hiding. So I'm going to click back to data selection. Okay, and now I'm going to go get my other stored URL right here. Copy it. And what I'm going to do now is I'm going to do a seasonal time series using the data. So I'll get rid of that and paste in the new URL. Say go, and then say reload. So now it's switched over to a seasonal time series. And because it's seasonal, we're going to get data points for the 4 seasons, which are winter, spring, summer, and fall. Okay, now, this may be the southern hemisphere, so they may be reversed, but at least we're going to take a look at the 4 seasons. Okay, I did this for 2011 to 2013, and you can't do this with a shapefile. So take a quick look at the map. I just drew a box around Paraguay. And in this case, we're looking at the TRMM precipitation rate monthly to get a look at the seasonality of it. And so once it's all set up, we click the green plot data button and generate that. A seasonal time series was something that was asked for a good long period of time, and our Giovanni developers were able to put that capability into the system. Okay, looks like it's almost done. Scrubbing, when you see that, some people are concerned about that, but that's just basically making sure that the data formats are compatible with the way Giovanni works with the data most of the time. Sometimes it will clear up discrepancies in the file format or the metadata. Okay, so here's our interannual time series for 2 years, and blue is December, January, and February, and black is March, April, May. And notice that each point, when I highlight it, actually gives you the value that it figured out for the average. So the red is September, October, November. And way down here, we can find out it's the dry season in the June, July, and August in Paraguay. So what we can see right here is that December, January, and February is when you get the most rain in Paraguay. So the heavy rains that caused the flooding were just heavier than usual for the rainy season in Paraguay. Now, one other nice little thing about this is if you wanted to look at just that point, you can click on these and eliminate them, and now we're looking at just the values for December, January, and February. If you click them again, they come right back. So it's one nice little way to look at the different types of data on a seasonal basis. You can also do this with, you can also look at it this way with monthly data. Okay, that's all for the demonstration. So now we return you to the presentation. Okay, now you probably saw that this was a late run data product. And iMerge has three separate product types. The early run, which is generating it as just about as quickly as it's possible. And you can see that it's about a 6-hour latency. So about 6 hours after the data is acquired into the PPM, the precipitation processing machinery. That's not the real name, but that's what does the processing. We will get a product, and that product will come right over to Giovanni. So it's going to be available quite quickly. Okay, it's not necessarily the best data. It's done with available data. You don't necessarily have ancillary data that helps you to process it. So we have a late run where you get more data products in, you can do a better estimate, and this is available about 18 hours after acquisition. And then the best data quality isn't going to be available until 4 months after acquisition. And this is when they can run all of the algorithms on it. They can make these estimates. They do different types of massaging, making sure that all the quality control and quality analysis has been done. And so for scientific purposes, to really look at the best data product quality, you want to use the final run. But if you're interested in what's happening right now, you can go with either the early run or the late run. So as I mentioned, okay, these are good for looking at weather events. And we know that right now there's a tropical storm system brewing off of Puerto Rico that could have some potential impacts on the United States mainland in a few days. So if you want to see what it's doing, you can use iMerge and Giovanni, both the early run and late run, and see where the rain is falling and potentially where it might be going. Okay, and so this is looking at our simple subset wizard, which is literally what it says. It's a quick way of making subsets using the data sets you select and temporal and spatial ranges. And this shows all of the stuff that's available in there, and here's the GPM iMerge. And you can get it in NetCDF or ASCII. Okay, now we talked a little bit about the applications. We had some applications that were built for Tropical Rainfall Measuring Mission. And those are currently on hiatus because we're waiting for retrospective reprocessing using iMerge in the TRMM era. They're going to use the same algorithms for iMerge to reprocess the TRMM data so that they basically fit together seamlessly across the entire period of TRMM into the iMerge era. Okay, so one of the things that we had was a way of looking at global and regional precipitation maps, which give you how much occurred, any anomaly, and also a normalized anomaly, which means percent of normal. And these were for daily, 30-day, 60, and 90-day periods. Really generated some nice things, and I talked to Zhang about this, and they're looking toward the end of 2017. So, you know, mark your calendars. Christmas 2017, you'll have a lot of new data products under the tree. Furthermore, we also have another collaboration with the United States Department of Agriculture, which was called the Crop Explorer. And the Crop Explorer provided both 10-day products and anomaly products. And this was, you'll see the screen for Crop Explorer. It's at the USDA, under the USDA web presence. And this is also something that will be available when the reprocessing gets done for iMerge. And we can develop new applications. We have some really skilled scientists and programmers here, and potential collaborations. We can set up new applications if you have an idea for them. Usually we say, you know, give us an idea and we'll tell you how long we think it might take. And I'm amazed at what some of our programmers and scientists can do here. So here's a quick look at what the current conditions look like. Okay, and this is looking at the 2015-2016. You can see here, you can see all the different regions. We had global, northern hemisphere, southern hemisphere, and many different regional products as well. Okay, and so this was for the most recent El Nino. And you can see this is an anomaly product, so the El Nino warm sea surface temperatures occur. You get a big rainfall excess on the eastern side of the Pacific Ocean. Okay, while at the same time, you get a big deficit on the western side of the Pacific Ocean. And this deficit, as many may know, leads to much more possibility of wildfires in the rainforests of the Philippines and Indonesia and Borneo and things like that. And there has been smoke, very thick smoke at times, emanating from these areas because of the fires that the rainfall didn't quench. Okay, this is a quick look at Crop Explorer. So if you Google Crop Explorer, USDA should be able to get here. And again, this is using our data to create products that are useful for agricultural interests. And here's another example from the most recent El Nino period. And in this case, we're looking at TMPA. TMPA is the multi-satellite product near real time, looking just at late last December, 10-day product, and you can see the amount of rainfall. You ask yourself, was this, more than normal, less than normal, usual? So then you can look at the percent of the normal, and you can see with these big areas of brown that the entire area was experiencing a deficit. Few areas down here getting a little bit more, but most of the area was very dry compared to normal conditions. Okay, so I hope that this has been particularly useful for the people interested in our precipitation data products. And so we have Tropical Rainfall Measuring Mission, we have Global Precipitation Measurement, and many different types of precipitation data. And we've shown you just a quick look at some of the different services that we have. Our unified user interface, which I think you'll really like as you get used to how it works. Giovanni, which we are developing further. Speaking with our developers, we're going to have a new capability available in just a couple of weeks, which is the overlay map. And so, for example, you can have the capability of putting precipitation over something like land surface temperature. You can have contour maps of one data product and color maps of another data product. So something I'm quite excited about. A lot of different things you can visualize with it. Good illustrative capability for classes, for students, and really you can see the data in another new way. Okay, and as I said, we have applications that support our various research activities, and which we do in conjunction with our partners. So, to finish up, this is our final slide, and you can see different places you can use to search and go for our different data, GPM data, TRMM data, our subsetting capabilities. How to find Giovanni, that's the basic URL for Giovanni shown right here, or just use Google, Crop Explorer, and this is where you find more information about NASA's precipitation data products. And if you ever have questions, we will take questions at our help desk. So that's what I have. So that's conclusion. We can take a little break, and you can answer some of the questions at the end. And then I'll be available, and Zhang will be available as well to answer questions that you may have. Thank you very much.
Okay, thank you, Jim. Thanks, everybody. What we're doing next is we are going to move to the final set of polling questions. We will give these questions about 2 to 3 minutes or so, and from there we'll move directly to the Q&A period. So for those questions that have been asked by participants earlier on, don't worry that you can't see them at the moment. They've been maintained in the Q&A log, and I will address those after we finish up with these final polling questions. So thanks so much, everybody. I'm going to put myself on mute here and give everybody an opportunity to check out these questions, and then from there we'll move to the Q&A. All right, fantastic. Thanks.
One mention. Do you still hear me, Jennifer?
Yes, I can.
One comment, if in the polling question about data combinations, one of the other NASA missions that's currently operating is the soil moisture never mind, I don't remember the exact name, but
Soil
SMAP,
Moisture Active Passive Mission.
Yeah, soil moisture active passive, thank you. And so I specifically singled out soil moisture data. Soil moisture data is available from the National Snow and Ice Data Center. And so you can use our precipitation data in conjunction with soil moisture data from them. We also have some soil moisture data products in Giovanni from the models. And if they're in Giovanni from the models, they're probably also available in our archives.
We'll have to get you on the hook, Jim, to do a webinar using Giovanni 4.
Yeah, well, actually, can I make a plug for what we're doing in November?
Sure.
Briefly, in November, for those of you that may be interested, we're going to be doing our third Giovanni online workshop. And this will feature many different applications to education. We're actually specifically theming this for the use of Giovanni in geoscience education, which can range from high school all the way up through graduate school and for professional audiences like meteorologists and things like that. And we have a really good lineup across the board looking at a variety of different data products in Giovanni to do this. And one of the first things we'll do on the first day is give you an update on Giovanni 4 and where it is. And by that time, we should have overlay maps we can demonstrate. And so I think you can tune in even if you're not specifically an education person for that first period on the first day for the update on Giovanni 4. And that will be, mark your calendars, November 15th through the 17th.
All right, we're going to give these questions just another 30 seconds or so, and then we'll move along to the Q&A period.
Check to see if Zhang has unmuted his phone so he can be available.
Okay, everybody, we're going to move along to the question and answer period at this point. Just a couple of things I wanted to make note of for everybody. You can sign up to receive announcements for upcoming webinars by going to our tinyurl.com Earthdata webinar. You'll also find our online Adobe Connect webinar catalog where you are able to download presentation files not only from this webinar, but from also previous webinars held in 2016, dating back to May of 2013. In the lower left-hand corner of your screen, you will find all of the links that were included within Jim's presentation. So if you were to click on all of those, you'll see the URL is being revealed in the box below, the menu bar below. That's a persistent feature. If you access this direct link recording later, you'll still be able to retrieve that information. And then to the right, in the lower right-hand corner, we have our presentation file. The PowerPoint has been uploaded as well as the agenda. With that, let's go ahead and take a peek at our first question. We had a question earlier, and I need to locate it here. So the question was, our first question, and Zhang, just a reminder to unmute yourself, you would press the *6. Our first question is, did I miss where you can request the raw data underlying the plots generated in Giovanni? And the further clarification to this is that he's looking for the values of the data points in the plot, for example, the spatiotemporal averages.
I'll take that one.
Zhang or Jim?
Yeah, I'll take that one because I've worked on something that will help to use the data. When you're done with the Giovanni plot, in the tree on the left side, there is a branch called downloads. And so when you go to the downloads, you can see the actual data files. And the data files are in that CDF, which you may have a capability of using in some software products. But several of our users were used to a capability we had in Giovanni 3, which was to download the data in ASCII text format, which can give it to you on a pixel-by-pixel basis. Now, one of the problems with that was that big downloads would stress the system for ASCII text. So it's not currently available in Giovanni 4, but what I was able to do was write a data recipe. I refer to our data cookbook at the GES DISC, and this allows you to import the NetCDF files into a Excel spreadsheet and then convert it into the format that we had in Giovanni 3, which is the lat, the long, and then the data value. Okay, and then I'm currently working on revising that because it had a size limit based on the number of rows and columns in Excel, and one of my colleagues here is a wizard with Excel and wrote a macro that made the conversion, and he revised the macro to allow bigger data sets. And I'm currently revising the recipe with that macro. So that's how you can do it.
Okay, thanks, Jim. And then Craig, so I think what we'll do is follow up in an email as well with that information. I have a few notes, and so either Jim or I can follow up with a direct link to the data recipe, and then the information provided, if that's acceptable. All right, and then our next question here is, are gauge data used to calibrate TRMM? If so, what is the possibility of accessing the gauge data used to calibrate satellite rainfall estimators?
That'd be one for Zhong if he knows, and then we have another person here that has developed a thing called data rods for some of our hydrology models that might also be able to refer to that.
So Zhong? Okay, Dr. Liu?
Can you hear me?
Yes, we can.
Okay, yes. Please use GPCC from Germany. The gauge data for the iMerge and TMPA are from GPCB, Global Precipitation Climatology Center. Yes. It's freely available for the bias correction.
Excellent. Thank you.
All right. Thank you, Dr. Liu. Let's see. Our next question is, what could be the problem or biases if some snow is at the ground?
Oh, the snowpile is very tricky right now. Right now, for iMerge, we use the pre-launch algorithm. So you have to wait for the version 4, which will be available as early as the end of this year. Yeah, hopefully that will get improved. Right now, it's not that good for the iMerge.
Excellent.
Yes.
Okay, thank you. Our next question is, how do you get the shape files, please?
From Giovanni?
I assume it says SHP files. Does this mean something else?
The shape files themselves are accessed from a different database. I know that the watersheds in particular are from the USGS. I'm not,
yeah, you can find the links from Giovanni. Yeah, I think they gave the links for the shape files.
Okay, that's one I'd have to research further because I haven't done that. But I know, like I said, I know the USGS watershed data. That's where the watershed boundary.
Yeah, I think in the future it would be nice if you can upload your own, shape file.
It's been discussed, but it's not something we can do right now.
Yeah. Actually, I'm looking forward to that.
Okay.
Well, Michael, we will follow up with an email as well. Okay. Our next question is, other than spatial resolution of 1/4 degree versus 1 degree, 0.1 degree, is there any difference between TMPA 3B42 and iMerge level 3 since they overlap in time?
Well, actually, I already published a paper, design analysis on that. Yeah, over the ocean, there are quite big differences. Over land, because due to the gauge, calibration, adjustment, actually the differences are not that big. Yeah, hopefully, in version 4, there will be a some differences. Yeah.
I'll have to mention Dr. Liu's paper because one of the images in the paper generated a image that was in our second class of the Giovanni Image Hall of Fame. So it was a very well done paper.
And also I noticed some people use either TRMM or GPM data for like a climatological trend analysis. I think please wait for the GPCP Global Precipitation Climatology, which will be also available at the GES DISC. And that's the CDR, climate data record. That one is much better than the other two.
You know about the time that might be available?
Anytime from now, actually.
Okay.
Yeah.
Okay, thank you, Dr. Liu. The next question is really more of a so there's a little bit of echo, so you'll need to make sure, computer speakers are muted if you're doing audio by way of telephone. Okay, the next question is, how can I use data from NASA satellites to create a simulation? So I don't know if this individual is referring specifically to within Giovanni or more generally, in which case that's a...
I'll speak to that in general. The only way that you can really use it in whatever else you're trying to do is to download it in the various methods that we showed you, access it, and then at that point you would have to decide what way to put the data in a format that can be used by the simulation that you're building. Okay, so we may be able to advise you further with more specifics on what you're trying to do. We've worked with people that have used it for quite a few different things. An example I'll just bring up is that we've had people from the insurance industry analyzing some floods that have caused damages and claims and things like that. So we have the capability, and we may be able to advise you on the best way to do it.
Okay, thank you, Jim. The next question is, stated here. I have a question regarding Giovanni 4. The platform has oceanographic monthly data such as chlorophyll, SST, but not in the daily data. So in the near future, will Giovanni provide the daily oceanographic data?
That's one that I can talk about. A couple different aspects to that. Some of the data products that are oceanographic data like chlorophyll, because of the fact that the world is a cloudy place, would be extremely biased by the averaging methodology that Giovanni uses. And so therefore, if you took the daily data and averaged them for a month, your data product would not be anywhere close to scientific quality. And this is something we've known about for a long time. The other aspect of this is the Ocean Biology DAC is currently spinning up their own Giovanni. And it will be under their particular jurisdiction as to whether or not they would put daily data and make it available, okay, with the constraints that I just spoke about, because we don't want people getting bad data from NASA. And so if you use Giovanni and all these different things happen, in addition to the fact that it's cloudy, the daily data has gaps between the swaths because it comes from a scanning radiometer, and that causes more gap problems. So it's unlikely that most of the data products would be available on a daily basis. But I will point out, one of the best temporal resolution data products for oceanographic data is the 8-day data products. And we are working and are very close to having that capability for some of the data products that we have. On our own system, we'll probably just have some of the more popular ones that can be used in a multidisciplinary fashion, like chlorophyll and SST, but the OBDAC may put all the ocean optics data and stuff like that for 8 days. So it's something we have to be very cautious with, because the way that the daily data is turned into a level 3 product is much more sophisticated than the way Giovanni averages data. That's my answer.
Yes, and we want our users to be aware of, a multitude of tools. Although we're focusing on, the TRMM and GPM and Giovanni, you might be able to also access those data products by way of the CDAS software.
CDAS is processing, but you also use Worldview for some of them too.
Exactly, and so I'll follow up with a couple. And we conducted a webinar using the CDAS interface as well. So I'll follow up for that user, Kunal, on that topic. All right, so the next question is, pardon me, TRMM data uses some terrestrial rainfall gauge stations. How can we be able to find out about them?
I think I mentioned earlier, they use a GPCC from Germany. The reason for the 3 or 4 months delay because we are waiting for those data coming in. Yeah, that's the major reason for the 3 or 4 months delay. Yeah.
What was GPCC again?
GPCC is a Global Precipitation project.
Climatology Center?
Yeah, yeah.
Okay.
Okay, thank you, Jim. And the next is actually more of a comment. The German gridded gauge data are available, but not the actual gauge values.
Oh, no. Yeah, I don't think you can get an individual gauge measurement. Yeah. All data are gridded, yes.
Okay, thank you, Dr. Liu. And moving here on to the next question. I would like to have the same possibilities of Giovanni, for instance, subsetting temporally and geographically time series generation, but using a programming language such as Python or R, and without using the web interface. Are there any API to access Giovanni?
We don't currently have that capability, and I've seen it. It's something that's built for some other types of plotting programs. It's something that has been under discussion, and in fact, Jennifer and I were just at a NASA DAC-wide user needs TIM meeting. It's a meeting basically of all the different user needs areas, and this was something that came up, was allowing more levels of machine access, not necessarily machine, but to allow you to put in other things. So it's not something that we can do right now with Giovanni. The best thing that we offer is the spatial and temporal capabilities to subset it for your periods. I should point out, I mentioned earlier that you can download the data for the maps. You can download the data for the time series as well in ASCII format, potentially put it into something else. But it's another level of type of things we would have to do programming-wise, and even allowing the capability of using the softwares like that.
Yeah, if you are familiar with OpenDAP or GDS, Grad server, you can basically use those links in your programs.
That's right. You can get the data into the program from there.
Right.
Okay, thank you, Jim, and thank you, Dr. Liu. The next question is, who has the daily gauge time series data?
That's a very good question. Normally, if you are a user, you have your own, gauge data. You basically use that data for some, initial evaluation. Yeah, those data are seems to me that are not very, open to everybody. Yeah. So actually, we don't have those data. Yeah.
One follow-up, and the user may already be aware of this, but for the United States, the USGS has all of its rain gauge data online. Mm-hmm. So if you're not aware, I can probably help you find it. If you are aware, then I probably told you something you already know.
Mm-hmm. Yeah, always do your own evaluation. Yeah, yeah.
Yeah, I actually use the rain gauge data for a paper.
Oh, okay.
And then combined with Giovanni. Yeah, so Jack said the East Sahel. No, I don't know. There are some really good hydrology and water resources people here at the DAC, and there's one other group you might consider talking with is our AirSet group, the ARSET, because they do a lot of applications, and they get questions like that in terms of the use of the data with other types of things. They may know, and we can put you in touch with a couple of those people as well.
Yeah, if you check TRMM website, the NASA TRMM GPM Precipitation website, they have a ground validation. They do provide some gauge data and the radar data. Yeah,
sometimes people are being very clever in getting data from different places that they can use for their research. So.
Mm-hmm. Yeah.
Okay, thank you. I don't see any further questions at the moment. Are there any further? Okay, here's a question. Does GPCC have a list of the rain gauge stations used for the TRMM data set?
I don't think they provide exactly the station names, but they do give you the number of gauges per grid point, and also how many gauge, for their product. Yeah, I don't recall to give you any, information about the gauge station.
The one thing that I might, in addition to that, is the people here that are making the data products, something like the GPCP might also have some information about where they get the data from, and that's a lot of that stuff's. I mean, at least some of the documentation is available online.
Yeah, but GPCP also use the GPCC gauge data.
Ah, okay. Well, they may know what ones they're using.
Yeah, I know. For example, in India, that's what I heard. They don't give out the gauge data. They only give you graded data.
Right. Okay.
Yeah.
Okay, thank you. The next question is, what is the design life for GPM, and when will the next core laboratory likely to be, when is the next core laboratory likely to be launched?
Well, as far as I know, actually somebody asked this question last month. The answer I got is GPM can last at least 2027, 10 years away. So I don't know when the next one will be, but I think people are discussing this possibility right now. Yeah.
I'll add too that frequently NASA will have a sort of a nominal 5-year lifetime, and then we're very happy when it lasts double that or more. Mm-hmm. So, but yeah, that's enough maneuvering fuel for at least a 10-year lifetime.
Okay. So I don't see any further questions at this moment. And just to let everybody know what we'll do. So if there are no further questions, what we'll do at this time is we will log off from the telecon portion, so you'll no longer have any kind of audio. But I will leave the virtual meeting space open for those of you who might be interested in downloading the presentation file or checking out some of those links. But please know that you'll still be able to access that information from the direct link of the recording. You won't be able to download files once I post it to YouTube, but I'll have it posted in 2 places. The direct link available on our online Adobe Connect webinar catalog, which is the tinyurl.com Earthdata webinar. You can always feel free to email me. If you have any questions you think of after, that would be perfectly fine to email me or Dr. Acker, and we will be sure to address those.
Or Dr. Liu.
Or Zhang Liu. And we're very happy you could join us today. Thanks to everybody. And I hope to see you at an upcoming webinar in the future.
And don't forget about the workshop in November.
And if you follow us on our social media channels, we'll have announcements up there for that as well. So that's.
You have a Twitter. To finish up, you have a Twitter account, NASA Earthdata, and we have a Twitter account, NASA_GES DISC.
All right, so let me type that into the.
Your Twitter is on the final slide. Ours isn't.
Yeah, so yours is at NASA_GES, right? For Twitter?
Exactly.
All right, everybody. Any
Thank
further
you.
questions? Going once. Let's see. I have to scroll down. There might be another. Thanks to all of you. All right, everybody. If there are no further questions, then we will log off from the telecon, and I hope to see you again in the future.
Hope you all enjoyed it. Bye.
Bye.
Thanks, everybody. Thank you, Dr. Liu. Bye-bye now.
Yeah.